in my next one. Hello, Mr. C.
Hey,
Hello,
good
Mr. C.
afternoon. How are you guys?
Good.
Terrible.
How'd the test go yesterday?
Difficult.
Thought it went good.
Well, remember, the test is, you get a perfect score on that, you're a genius type thing. So, the difficulty level for some of those questions is going to be crazy high. But you should have encountered a bunch of questions that you knew.
Working off of that, I watched this interesting video about a Greek who made a right triangle by walking around a mountain to dig through it.
Yeah, that's how they kept things straight, right? Basic trigonometry back then. So when they were taking surveys, surveying land is just a big application of trigonometry. All right, any questions on the homework?
None for me. I've already sent my
Nope.
video.
Okay. Yeah, I shouldn't call off the answers since everybody has to send it in on Teams. That would be silly. It's not in front of you. Okay, so I'm not going to call out the answers, but if you do have any questions, make sure you're gonna encounter that circle formula in Algebra 2, pre-calculus, calculus. That one's used. Not like daily, but it's certainly used frequently. What was the other form? Oh, distance formula as well too. Both the distance formula and the circular formula are used quite a lot. We're going to do 3.2 today. We're going to do an algebra review tomorrow. I believe it's the last algebra review of the book. And then we're just going to march our way through. Your calendar you're looking right here through the chapter 13 test takes us 2 weeks before the end of school. That second to last week, Monday, Tuesday, we'll continue chapter 14. And then Wednesday, Thursday, Friday, we'll do semester final review. And then that last week was just half-day schedules with make up semester final on Friday. So you won't have to come to school on Friday. Here is your homework. Chapter starts off kind of slow. It's another review day, really, from Algebra 1. So is 13.3. And then 13.4 is when we get into the 13.4, which is on Monday. 13.4 is when we get into the brand new. You may have heard about this. You may have talked about a little bit of this in physics, but 13.4 is a brand new stuff. And then 13.5 is reviewed. Finally, 13.6 and 13.7. Is there a 13.8? Yep, 13.8. Those are all new stuff. So chapter 13 is a mixture of old and new. Old and new. I don't think this is going to take too long because today the class is on slope of a line, and you're like, well, I did that in pre-algebra. I did it in Algebra 1, and you're going to do it in geometry as well, too. The only difference in geometry is that we prove everything. So all those formulas that we had for slope, well, we're going to prove them today. All right, so this should be a straight up review. There should be nothing here. You guys should have remembered this. I would think that on the PSAT test, you were asked a few times about slope for the math part. If you remember way back pre-algebra, like the first time you encountered slope, this was the definition you had. For instance, this is my 7th grade definition for pre-algebra, course 1. And they just define it as the steepness of a line, how steep a line is. So the red line right there, well, it looks pretty darn steep. This red line doesn't look as steep, and well, this one looks like opposite of steepness, right? And you guys already know about slope, but that's, literally that is the definition. It's just the steepness of a line. Now we assign a number to that steepness, and that's what this entire class is on, that number and how they get that number. All right, a quick note, because we're talking about lines, notice here's an example of a line in red. The steepness never changes, right? Anywhere along that line, the steepness is exactly the same. As soon as we have a curve of some sort, then it changes. But we're talking about slope of a line. It doesn't matter where you measure it. It is always the same for each individual line. All right, so for lines, slope never changes. That's not true for parabolas. The slope is constantly changing on a parabola. If I make, I'm sure I know Ben has done this. If you graph the sine of x on your calculator, you get this S-looking thing, and that the slope of that line is constantly changing. All right, so that was our 7th grade definition. By 8th grade, we had the more formal definition of slope. We give slope the letter M. It's kind of lost to history why they chose the letter M. There's some theories, but there is no definitive reason why we use the letter M for slope. But M is the letter we use for slope. It is defined further in 8th grade as the change in the y values over the change in x values. In other words, it's a ratio or a fraction where you basically see how far you're going up versus how far you're going left or right. And that's where we get this term rise over run, although you won't find that in a math book, rise over run. That's what all math students around the world use to calculate slope, is rise over run. I throw this one out there because you did see it last year in Algebra 1, and most math books, whenever they talk about slope, they'll use this definition as well. That triangle symbol, well, it's geometry. You'd think that's the triangle symbol, but now it also turns into the delta, and delta is what we use for the word change. So that's where we get the change in y over the change in x. And that seems complicated because you are in geometry class, and that's the same symbol that we use for triangle, and I agree. Okay, so let's see. Slope is the change in y over change in x. It's rise over run. We would like to get a formula. That's kind of what we're building up to, but we're not ready to do that yet. All right. Okay, so I'm going to slowly work my way to get that formula. But I do want to point out that the numbers assigned, sometimes you have positive slope and negative slope. That needs to be a bit more defined because that's just me throwing that out there. And I will define it later in the class, but I just want you to remember that positive slopes go upwards. If you think about as we read from left to right, if you're going up the line, that's a positive number. If you're going down the line, that's a negative number, if you think about it in that. For the civilizations that don't read from left to right, I don't know how their math teachers explain this to them, but we have it easy. The number is just like the way we read it, from left to right. Directly in the middle between a positive and negative is the number 0, and obviously a horizontal line, as you learned last year and the year before, has a slope of 0. I will also prove that to you today. So, by the way, I threw it out in 8th grade. I just basically said, hey, what's in between positive and negative? And you all said 0. It wasn't much of a proof, so we better prove that today. All right, so we're going to do two things. First off, we're going to calculate slope if I give you a graph of the line. So I'm not going to give you the equation. I'm going to give you the line itself on a graph and ask you to calculate the slope. And if you remember from pre-algebra, I called this the monkey method because, you know, I could teach a monkey how to do this. It's not that complicated. All right. Before we do that, though, I need to remind you of this word lattice, and then I use it with the word lattice point. And that is where the intersection of the grid lines come together. So for instance, let me pull up a pen here. Come on, program, work. Let me pull up my pen. There it goes. So if I put my pen right here, right smack there is a lattice point. Where the grid lines come together right at that intersection is called a lattice point. Well, there's another one right here. In fact, there's lots of them. The origin is a lattice point as well, too. So when we graph points, to calculate slope, we want to look for these things called lattice points to do our calculations. All right, hopefully you remember that from Algebra 1. Well, here's a line in red there. I've already provided you with 2 points, a blue one and a green one. And notice those 2 points are at lattice points. Remember, any line has an infinite number of points. I'm just choosing 2 of them, and 2 that are, there's other lattice points here, by the way. So for instance, if we think about, well, you guys already know about y-intercept. Why is my pen being difficult today? Come on, pen, pop up. It's not popping up. There it goes. All right, so the lattice point right here, there's a lattice point, there's a lattice point here, there's lots of lattice point. I just chose 2 of them, and they're outlined there with big dots. All right, so let's see how this works. Well, we know that slope is defined as the change in y, in other words, how far you go up or down over the change in x values, or the rise over the run. You simply need to remember, if you go up, that's positive. If you go down, that's negative. If you go left, that's negative. Think about the number line. If you go to the left, that's negative, right? And if you go to the right, that is positive. So let's see, rise over run. So if I go from, and it doesn't matter which dot you go from. I'm going to go from the blue dot to the green dot. My only rule is I got to stay on a line. So there's 1, 2, 3, 4, 5, 6. So it looks like I rose 6. So that's my rise. And my run is, let's see, from the blue where I left off, I go over 1, 2, 3. I have a run of 3. Now, slope is always a reduced fraction. 6 divided by 3 is 2. So we get a slope of 2. If this was a 7th or even an 8th grade class, I would spend a whole lot of time asking questions, making sure you had full understanding, but this should just be a reminder of how you calculate slope. So let's look at this one. If I go from the blue dot to the green dot, well, this time I'm going down. Looks like I'm going down 2. And then I'm going to the right 1, 2, 3, 4, 5, 6. So I'm going right 6. Now down was in the negative direction, and to the right is in the positive direction. So reduce that fraction, we get negative 1/3. McKinley, is this all sounding familiar?
Yes.
Ben?
Yes.
Okay. I also want to point out there's no reason you have to go from blue dot to green dot. If you wanted to go from green dot to blue dot, well, let's see. If we do it in that direction, well, we're not going down 2, we're going up 2. Draw, darn you. We're going up 2. So from green dot to blue dot, it looks like we would go up 2. So that would be a rise of 2. But this time we would go left 6. And that would be a negative 6. And notice that fraction still is equal to negative 1/3. We made this nice parallelogram right here, a rectangle, when we did that. So it doesn't matter which direction you go. If you want to go from right to left or left to right, that's fine. Don't confuse that with what I said earlier about if you look at just the red line itself and you go from left to right, the line is going in a downward direction. So we should already know that our slope is negative. Okay. So that's called the monkey method. If you were here in class, I would say do this box right here. Notice that 2 of the ones, the upper left and the lower right, already have points. The other ones don't. So if I were to do that, I would have to find lattice points. So my upper left one, let's see, I'm going down 1, 2, 3, and I'm going right 1, 2, 3, 4. So negative 3/4. But on the lower left one, check it out. Look, there's no points there. First thing I got to do is find 2 points. There, I found 2 points. Now, there are more lattice points. In fact, there's one more, I believe. Yeah, just one more lattice point. But those were the 2. And any 2 lattice points work. So for instance, oh, by the way, the slope would be what? Up 1, 2, 3 over 2. So 3 over 2. Now, notice if I did not pick that lattice point, but instead pick this one and this one, notice I'll get the same thing up 1, 2, 3, 4, 5, 6. So I'm going up 6, and I'm going over 1, 2, 3, 4, over 4, and that still reduces to 3 over 2. So it doesn't matter which 2 points you pick, you will always get the same slope. All right, so I'm not going to bore you with the rest of those. If you have issues calculating slope, send me a chat or something like that. I can give you some individual help, but I think you guys should be okay of calculating slope. Notice on that last one there, we've gotten up 4 over 4. That would reduce to 1. And whenever it reduces, it probably also tells you that there's another lattice point that you missed. Notice I could have gone from here to there, up 1 over 1, and I'm done. Any 2 lattice points will work, though. The ones you pick farther out, it just means you have more reducing to do. All right, so let's continue that train of thought. Now that we know how to calculate slope, we can graph some lines. So remember doing this, recall that the slope of the line never changes. So as long as I have one point and the slope, I can graph a line pretty easy, right? Because the slope never changes. So read this question. It says, sketch the graph of the line that passes through point 1, 2, and the line has a slope of 3 over 5. Well, since we know that the slope never changes and it goes through, there's 1, 2 right there, I simply need to apply the slope to that red point. Remember, 3/5 is the slope. The slope is defined as rise over run. So I am rising 3 and I'm running 5. Now, 3 is positive and 5 is positive. So that means go up 3 and right 5. So I go up 3 and right 5. And notice that second dot that I just graphed is up 3, right 5. Technically, you're done right there because 2 points define a line. I would always, just to ensure you didn't make a silly mistake, put 1 more point. Notice if we try to do right 5, we're out of squares there. So we can go in the opposite direction. We would just simply do the opposite slope. To find the opposite slope, you simply take the opposite of the rise and the run. Well, the opposite of 3 is -3. The opposite of 5 is -5. Notice -3 over -5 is 3/5. So if I go way back to my original dot that I graphed at 1, 2, and instead now go down 3 and left 5, I wind up right there. So from that original dot at 1, 2, if I went down 3, left 5, notice I get a third point. And now, because all 3 dots there make a nice straight line, I can be assured that I probably didn't make a mistake. Still a chance, but you have to make a really crazy a double mistake in order for that to happen, where you get a nice straight line. When this goes bad, you get a V or something like that. All right, like I said, hopefully you remember. McKinley, you remember doing this last year?
Yes.
Okay, cool. So I'm not going to spend too much time on here tonight for homework. They're going to give you some points and some slopes. I do want to point this one out to you. Notice, well, there's nothing big deal about the 0.05, but there is something about the slope. Notice the negative is in the middle of the fraction. It is your choice of where that negative goes. You can put the negative on the top, the numerator. You can put the negative on the bottom, the denominator. You can't put it on both because this slope is negative, right? So that negative right there either needs to go on the 2 or the 3, but not both. So if we put the negative on the 2, that would be -2/3, right? That would be down 2, right 3. If we put the negative on the bottom, then that would be +2, -3. So in order from the going from the original point at 0.5, now we're going to go up 2, left 3, and look, we made a nice straight line right there. Be careful with the negatives. Remember the negatives, if there's a negative slope, the negative either goes on the numerator or denominator. If there's a positive slope, you can have both the numerator and the denominator negative, because a negative divided by a negative is a positive. So positive slopes, if you want to go in the opposite direction, it's basically a negative over a negative. All right, as I said, I'd probably have you practice this if we were in class, but we're not in class. We will be on Monday, so 2 more days. But the process is done the same. So from the original dot at 3, 4, I go up 1, right 2, because the slope is 1/2. If I want to go in the opposite direction, well, let's see, the opposite direction would be -1. I'm not sure why it's not drawing. -1 over -2. So if I do that from the original point of 3, 4, then down 1, left 2. On the second one, let's see, I'm at negative. Why is that dot on -1, +1? It should be on -2, 2. Well, there's negative. I just have the animation out of order here. So -2, 2, and a slope of 3. So up 3 over 1, up 3 over 1. There's my 3 dots. If I wanted to go in the opposite direction, I didn't in this case. So let's see. A 3 over 1 is the slope. So if I go in the opposite direction, that would be -3 over -1. So let's see, from the original dot of -2, 2, or -2, -2, I go down 1, 2, 3, and over 1. And you can see I would get a dot right there. And that lines up with my line. Last one there at the origin, -2/3, so down 2 over 3, or up 2, left 3, or up 2, left 3. My animation again is out of order. I have to fix that. All right, any questions on graphing a line? Graph paper helps, but it's not critical.
I have none.
All right. Hopefully you've noticed either the last 2 years or this year, you've noticed that the slopes as you go from left to right, if it goes in an upward direction, the slope is positive. And if you go in the opposite direction, then it's negative. I absolutely have to talk about the formula now. So let's do this without graph paper. In other words, let's calculate slope without graph paper. So I'm going to derive the formula that you used last year that I basically said, hey, trust me, here's the formula, it works. And you all did trust me. But this time I'm going to show you where the formula comes from. So where does the formula come from? It comes from the definition. We've defined slope as the rise over the run or the change in y over the change in x. So let's just draw a general case of slope. So I'll start with a Cartesian coordinate plane. There's the origin there. I'm going to draw a line somewhere on the plane. Now notice I put it in quadrant 2 and 1, but I'm not going to claim it's in 2 or 1. I'm just going to say there's a line on the coordinate plane. To calculate slope, we need 2 points. So I'm going to put 2 points on my line. And then I'm going to write the coordinates of it. So this is what this chapter really is about, is this step right here. When I say to write the coordinates of those 2 red dots, we got a problem. The problem is there's no numbers here at all. There's just O for origin. Well, we can still assign, well, not necessarily numbers, but we can assign variables. So the dot on the left, and it doesn't matter which one you start with. I'll just start the one on the left. The dot on the left, well, I'm going to assign the coordinates x1, y1. Hopefully start sounding familiar. For the second dot, I'm going to assign the coordinates x2, y2. Now notice there's no numbers involved. There's names, but there's no numbers involved. And I now know where those 2 points are. Now granted, they're all variables, but I do have at least values for them in the sense of variables. Now, how are we going to calculate the slope? Well, we're going to use the monkey method. So we got to figure out how far it is to go up and then to the right. And we're going to use a trick that we used with the distance formula. Remember, with the distance formula, we had basically the same idea, and we made a right triangle. So construct from x1, y1 a horizontal line that goes through that point. And then from x2, y2, construct a vertical line that goes through that second point. Notice we would make a right triangle. Well, we're not going to need the triangle portion. What we're going to need is that third dot where those 2 dotted lines intersect. That dot there we're going to call as x2, y1. Now, where am I getting that from? Notice where the 2 dotted lines intersect. How far left is that? Well, or left or right is that of the origin? Well, it's x sub 2. That's how far it is to the right. It's the same value as x2, y2. That's how far it is to the right. Well, how far is that intersection of those 2 dotted lines up and down? Well, it's up from the origin. How far up? It's the same as 0.1. It's y1. So that's why that, I didn't draw a dot there, but that's why the intersection of those 2 dotted lines is at x2, y1. This technique that I'm showing you is a very common technique that we will use multiple times in this chapter, where you're not given any values. You simply take the shape, you put it on the coordinate plane, and you figure something out based upon the geometry of the problem. Okay, so let's take a step back. What were we trying to figure out? Oh yeah, I'm trying to figure out the rise and the run. I'll do the run first. Notice if I go from the left red dot to the right red dot, well, that would be that a horizontal dotted line. And how long is that? I don't need to use the distance formula. I simply, because it's horizontal, I simply take the 2 x values, x sub 2 and x sub 1, and subtract them. Now, I don't need absolute values because x sub 2 is to the right of x sub 1. So it's on the number line, it's got to be a bigger number. So I don't need absolute values. I simply need to take the x values and subtract them. Well, that's going to be my run. Well, how do I figure out my rise? Well, it's the same logic there, where the 2 dotted lines intersect, has a y value of 1 or y1, and directly above it, it has a y value of y sub 2. So if I subtract those 2, I would get the distance of that vertical dotted line. And there's my rise. I take those 2 things in yellow, write that as a ratio, and that, ladies and gentlemen, is what I told you last year. Trust me, this is the formula. I'll prove it to you in geometry. And by the way, I just did. So this needs to go somewhere in your notes. For some reason, we don't get a theorem out of it. At least I don't think we do. Yeah, we don't get a theorem out of this. But that's basically what you're going to use tonight to do almost all of your homework. Okay. And you should remember this from last year. Usually when you take PSAT, SAT, they'll throw this for. They didn't on today because I remember looking at the resource card for 10th grade. This formula is not on there. But the formula for slope, M, remember I said M is the variable we use for slope. It's lost to history why we chose M. Nobody really knows. But we do choose M. And it's y2 minus y1 over x2 minus x1. And that literally is the change in y over the change in x. So that is the formula. Now it says slope M. That's kind of repetitive there. It just simply should say M is equal to y2 minus y1 over x2 minus x1. All right, we okay to move on?
I think so.
Okay. All right. So tonight for homework, this is kind of what it looks like. They're going to give you they might give you a graph, or they might just give you 2 points, right? If they give you a graph and the points are already on there, we'll take those 2 points. You don't need to make a right triangle. You simply need to apply the formula, the slope formula. The slope formula is y sub 2 minus y sub 1 over x2 minus x1. So the hardest thing about this process is figuring out which one you want to be 0.1 and which one you want to be 0.2. And the answer to that is it doesn't matter. Whichever one you want to be 0.2, it's 0.2. Whichever one you want to be 0.1, it's 0.1. No, I don't need to rewrite these. I simply just need to label them, right? So the labeling aspect, for instance, if I want to call 5,4 to be my 0.1, I can. I want to call that second one to be my 0.2, I can. It doesn't matter how you'll get the same answer. And then it's just simply a plug and chug thing. So it says y sub 2 is 3 minus y sub 1 is 4, so minus 4 over, let's see, x sub 2 is 3 minus x sub 1 is 5. Simplify that fraction. That would be negative 5 over negative 2. Negative divided by negative is a positive, so we get 5 over 2, and that's your slope. All right. Most likely, they won't give you a graph like I'm giving you right here. They're just simply going to give you the 2 points. So your formula, or what you'll be given, might be something that looks like this, where they give you these 2 points and say, calculate the slope of the 2 points. Just to show you can do it either way, we'll still get the same answer. This time I will call, no, I did it the same way, sorry. I'm going to call that one 0.1 and that one 0.2. I'll do it by hand here to show you with the same number. Plug and chug. So notice there's a pattern if your second value is 0.2. So it would be this minus this over, whoops, I did it backwards. Sorry. I did my x's first. This minus this over this minus this. That's the pattern. So let's see. That would be what? 2 minus 5 over 7 minus minus 2. 2 negatives make a positive, so that would be negative 3 ninths, which would reduce to negative 1/3. Now, what would happen if I changed the labeling around? Well, the numbers would flip-flop around, but watch, we'll still get the same thing. If I want to call this 0.2 and this 0.1, it's kind of sloppy, but you'll get the idea. Let's see, the y's would give me 5 minus 2 over negative 2 minus 7. And notice we still get negative, 3 over negative 9, which reduces to negative 1/3. So that's the same as that one right there. Okay. So it doesn't matter which one you call 0.1, 0.2. What matters is when you label. I've got a big honking mess here. It matters when you label and you plug in the numbers correctly. A lot of mistakes, common mistakes on this is simply you get too big for your britches and you say, I don't need to do that labeling, then you make a silly mistake. So I would always recommend labeling. Let's go back to this thought about positive and negative, right? So if the line extends upward from left to right, it's positive. If it drops down from left to right, we say it has negative slopes. But that would leave a question of what happens for vertical and horizontal lines. The number one piece of fact that is forgotten by almost all math students, they understand slope, they even understand how to figure it out, but they forget whether which one is a zero and which one is undefined, whether it's vertical or horizontal. So hopefully by the time you get to pre-calculus 2 years from now, that this is so ingrained in your memory that there's no chance of you forgetting it. But by the way, let's prove what the answer is. So here's a vertical line and a horizontal line in the red right there. Let's figure this out. Vertical line first. Well, we're supposed to subtract the two y values. Well, they have different numbers. So that would be what, y2 minus y1. But check it out. The x values would be exactly the same. Both red dots are the same distance left to right. In fact, it's to the right at a certain value. So in other words, when you did that, you get a 0 in the denominator. And notice we can't ever divide anything by 0, which is why the vertical line is undefined or no slope. But the horizontal line, well, we have no up and down here. So the rise is 0. But the run would be a value. So the 0 on the top is perfectly fine. 0 divided by anything is 0. So all horizontal lines have a slope of 0, but all vertical lines, we say no slope or undefined, either one. The book, I'm looking at the book and it says use the word not defined, and that's fine. Either no slope or not defined or undefined. Any one of those three is a good answer. All right, any questions?
Anybody? No.
None for me.
I told you today would be very short. So McKinley, look at the number 1. Is that a positive or negative slope?
Positive.
Ben, can you do that math in your head?
Yeah.
Do it.
Number 1.
Yep.
All right. Well, we have 2 minus 1, which gives us 1. And then we have 3 minus negative 2, but that's plus 2. So we have 1 over 5. That's the slope.
That's the slope. Anna, look at number 2. Is that a vertical or horizontal line?
Horizontal,
So what's the slope before even doing any calculation?
0.
You got it. And I think we can call it quits right there, because I'm just going to say that there's nothing challenging about today's homework. There is some graphing. We did a couple of examples, and they're going to give you a point, and they're going to ask you to graph the line that goes through the point that has a specific slope. Just write rise over run, and you'll be perfectly fine. If the slope is negative, apply the negative to either the numerator or the denominator, whichever one floats your boat, you'll be good to go. All right. Any questions on anything I covered today?
None for me.
None for me.
One quick note. I'm looking at the homework here. It says for questions 12 through 15, it says find the slope and the distance. So you will be using the distance formula for that portion of it. All the answers they left as exact values, so they left them as simplified square roots. They didn't grab a calculator. So I'll give you one. Well, 13, the answer is 2 root 29 for the distance. So there's your pro tip for tonight. All right, we're gonna do algebra review tomorrow. No big deal. I believe it's on exponents, if I remember right. Could be wrong, but I think it's yeah, no, it's on exponents. It is on exponents. All right. If there's no question, well, if there is, just send me a chat. You guys have a wonderful, wonderful day, and I'll see you guys tomorrow.
Bye, Mr. C.
See ya.
Mr. C.